Students, welcome to the next video of derivative. In today's video we are going to see the derivative of implicit function. Now let's revise the implicit function. In function chapter we had already seen what is the implicit function. Now once again let us do the revision of implicit function. So class, implicit versus explicit. Okay, there are two types of function. One is a explicit and the other one is a implicit type of function. Explicit, the function can be expressed as an equation in terms of one variable like this. Y is expressed in terms of x variable. Okay, y is expressed in terms of x, or x is expressed only in terms of y. So suppose that is equal to y plus 1. Okay, if one variable is expressed only in terms of one variable, then that function is known as a explicit function. Implicit function, the function is implied by an equation. You can't separate the variables. See here, you can't separate x and y, right? You can't write x only in terms of y or y only in terms of x. If both the function are mixed, both the variables are mixed, then that type of function is known as a implicit function. Suppose y is equal to sine x plus y. Okay, then e raised to x plus y. All these are implicit function. When x and y both variables are mixed, then that type of function is known as a implicit function. Okay, now implicit function is clear. Now let us see how to find the derivative of implicit function. So let's see the first example. Here question is find dy upon dx if x square plus y square equal to 4xy, right? Now function is an implicit function. So for implicit function what we have to do? We have to directly differentiate. Okay, we will directly differentiate this function. So derivative of x square is 2x. Derivative of y square, here in y also we have to use the formula of x only. Okay, same formula. We know that x raised to n is n into x raised to n minus 1. So y raised to n will be n into y raised to n minus 1 into derivative of y. So here it comes dy upon dx. Okay, whenever you are using formula, derivative formula in y, okay, then you have to write this dy upon dx term. So as you can see, derivative of x square is 2x, derivative of y square will be 2y into dy upon dx. Okay, dy upon dx will come because we are using formula in y. That is equal to 4 is constant. Now x into y means u into v rule. So 4 is common, then bracket x into derivative of y. Derivative of y is dy upon dx, then plus y into derivative of x. Derivative of x is 1. Okay, so by dividing by 2 we get x plus y dy upon dx is equal to 2x dy upon dx plus 2y. Okay, now collecting terms in dy upon dx in left hand side. We'll take all the dy upon dx term on left hand side. Okay, and remaining terms will be on right hand side. So this y dy upon dx minus 2x dy upon dx, that is equal to 2y minus x, right? This is the term which I am getting, right? Now dy upon dx is common. right? So by taking dy upon dx common, we will get y minus 2x. So y minus 2x into dy upon dx, that is equal to 2y minus x, and hence dy upon dx is 2y minus x upon y minus 2x. Okay, this is the derivative. Now see one more example. If x square plus y square plus xy minus y equal to 0, then find dy upon dx at 1, 2. Okay. Now we have this term which is an implicit function because x and y both variable are mixed. Now directly we have to find the derivative. So let's start with derivative. Derivative of x square is 2x. Derivative of y square is 2y. dy by dx plus derivative of xy means u into v rule. So x into dy upon dx plus y into 1 minus derivative of y is dy upon dx, and derivative of 0 will be 0. Okay. Then that is equal to 2x plus 2y dy upon dx plus x dy upon dx plus y minus dy upon dx. Now collecting terms with dy upon dx on left hand side, we get, take this dy upon dx common, so we get this 2y plus x then minus 1, right? That is equal to this 2x will go in right hand side, so it will be minus 2x, then y will go in right hand side, so it will be a minus y. Now we'll take minus common, so 2x plus y. So finally dy upon dx will be minus 2x plus y upon x plus 2y minus 1. Okay. Now we have to put the value. So dy upon dx at 1, 2 will be minus 2 into 1 plus 2 upon 1 plus 2 into 2 minus 1. So that is equal to minus 4 upon 4 means minus 1. Okay. So if point is given, that means x and y values are given and we have to substitute that x and y values. Clear? See some more example. Here e raised to y is equal to e raised to x plus y. Okay. Then we have to prove that dy upon dx is equal to log x upon 1 plus log x whole square. Okay. Now what we are going to do, we are going to take log on both the side. Why we are taking log on both the side? Because here x raised to y is given, that means variable raised to variable is given, and there is no derivative formula for variable raised to variable, and hence we are taking log on both the side. Now by taking log on both the side, we get y into log of x is equal to x minus y into log of e. Okay. Now y into log of x is equal to log e will be 1, right? So y into log x is equal to x minus 1. Okay. So that means again I am taking this minus y on left hand side. So what I will get? I will get y plus y log x is equal to x. So y common, so 1 plus log x is equal to x. So y is equal to x upon 1 plus log x. Now differentiating with respect to x. So derivative of y is dy upon dx. Here we have to use u upon v rule. So that is equal to v into derivative of u. Derivative of x is 1 minus u means x into derivative of v. V is 1 plus log x and derivative of constant is 0. So that's why derivative of 1 will be 0. Derivative of log x is 1 upon x whole divided by v square means 1 plus log x whole square. Okay, so finally what I am getting? I am getting 1 plus log x minus 1, because this x cancel. Okay, so 1 plus log x minus 1, and again 1 cancel, 1 minus 1 will be a 0. So finally I am getting log x upon 1 plus log x whole square, hence proved. Then see one more example of similar type. Here e raised to y is equal to y raised to x, and we have to prove that dy upon dx is equal to log y raised to square, log y whole square upon log y minus 1, right? Now again see, right hand side is variable raised to variable, and hence we have to take log on both the side. So we will get y into log e is equal to x into log y, but log e is 1, right? So finally we'll get y is equal to x into log y. Now we will differentiate this function. So derivative of y will be dy upon dx, that is equal to u into v rule. So x into derivative of log y is 1 upon y dy upon dx plus log y, okay, into derivative of x, but derivative of x is 1. Okay, now collecting terms dy upon dx on left hand side, so we will get dy upon dx minus 1 upon y dy upon dx, that is equal to, sorry, x upon y dy upon dx, that is equal to log y. Okay, now 1 minus x upon y dy upon dx is equal to log y. Okay, so by cross multiplying we get y minus x upon y dy upon dx is equal to log y, and hence we get dy upon dx as log y into y upon y minus x. Now substituting for y from 1 we get log y into x into log y upon x log y minus x. Okay, so by taking x common from denominator we get x log y minus 1 in denominator, then x cancel, and finally we get dy upon dx as log y whole square upon log y minus 1. Okay, see one more example. If e raised to x plus e raised to y is equal to e raised to x plus y, then find dy upon dx. Okay, now differentiating with respect to x, we get derivative of e raised to x as e raised to x, derivative of e raised to y as e raised to y into dy upon dx, and derivative of e raised to x plus y as e raised to x plus y into derivative of x plus y. So derivative of x is 1 plus derivative of y is dy upon dx. Now we are going to collect the dy upon dx term on left hand side. So this term remain on left hand side and this term will go in left hand side, right? So by taking dy upon dx we get e raised to y minus e raised to x plus y, that is equal to e raised to x plus y minus e raised to x. Okay, now from this we'll take e raised to y common, so this term is e raised to y into 1 minus e raised to x, right? Here we'll take e raised to x common, so e raised to x into e raised to y minus 1, and finally we'll get dy upon dx as e raised to x, this upon e raised to y into 1 minus e raised to x. Okay, so either this or this term. So with this I am concluding this video. Thank you students. Have a good day.